This is our lesson over section 5.3 in pre-cal. We have decided to divide the lesson into two parts. This morning we will be covering, we'll call it 5.3A. Actually, we're going to assign problems 1 through 4 all and 5 through 31 odd. We're going to go through and work these today. This afternoon, send me questions if you have any on the problems. Again, you're going to send questions as problem so-and-so, problem number 21 or whatever it is, and I'll try to get some of those answered in the afternoon. So we're going to go 1 through 4 all, 5 through 31 odd. We'll try to answer questions this afternoon. You can also ask them again tomorrow. But in the morning, then we're going to do 5.3B. And we'll add to the assignment tomorrow for that. But right now, we're going to go 5 through 3A. Now, on these, there are 6 trigonometric functions. And before we get through, you're going to be able to graph all 6. What we will do in order to graph these trig functions, you're going to remember and memorize what is called a base graph. Sine graph, y equals sine theta, this is the base graph. Cosine theta, this is the base graph. We will say that this graph has an amplitude of 1. That means that when you draw a line down through the middle of it, it'll go up 1 and down 1. It has an amplitude of 1. It has a period of 2 pi. This thing goes just completely, keeps going forever in both directions, but every 2 pi, it will have a complete rotation on it. And so we've got 2 pi. Now, when I label this, there's a reason I'm going to label it this way. You'll be better off if you do it. It just makes it easier to do. 2 pi is the period, so I put 2 pi here. Half of 2 pi is pi, so I put pi here. Half of pi is pi halves, and pi halves plus pi would be this part right here, which would be 3 pi halves. If you'll get in a habit of labeling them here, 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 makes it easier to do. Now we can do it in radians or we can do it in degrees. Again, as we've talked before, you need to be able to think in radians, you need to be able to think in degrees. We know that pi radians is equal to 180 degrees. 180 degrees equal pi radians. Therefore, 2 pi radians would be 360 degrees. And again, I'm going to label it in this order. 360, half of that is 180. Half of that is 90. 90 plus 180 is 270, like so. I want you to memorize this base graph. In like manner, I want you to memorize the base graph for cosine. Again, the amplitude is going to be 1, so I go up to 1 and down to -1. The period is 2 pi or 360, so I've got 2 pi. Half of that's pi, half of that's pi halves. Pi halves and pi is 3 pi halves. 2 pi is the same thing as 360 degrees. Half of 360 is 180. Half of 180 is 90. 90 plus 180 is 270 degrees. Again, I want you to have the base graph for sine and the base graph for cosine memorized. We will use transformations. We can graph any sine function, any cosine function by using transformations of these graphs. Now, when we hit the transformations in Algebra 2, in college algebra, and pre-calculus earlier this year, we've used transformation. Now, the only one that's going to hit you is going to be new is called a phase shift. I've noticed this book, instead of calling it a phase shift, they're going to call it a horizontal shift. Perfectly fine. Phase shift, you're probably going to hear me say phase shift instead of horizontal shift. They say horizontal shift, I say phase shift, we're saying the same thing. Okay. I'm going to make up a problem. This problem's not in the book, but I'm going to make it up because I want to illustrate a point to you and some stuff that I want you to make sure you understand. If I have y equal to 3 minus cosine 2x minus 4, like so, and I want to know, I'm going to find the amplitude, the period, the phase shift, also called horizontal shift, and the vertical shift. Also, any reflections. Okay, the amplitude is the number that appears in front of the cosine. I think I'm going to add something else to it. I'm going to put a 4 right here. So I got 3 minus 4 cosine, open parentheses, 2x minus 4 close parentheses. Usually we see it written in this form if we're talking about radians. If we're talking about degrees, we'll usually see it written like that. I think in this section they're using radians. Let me look at that. Yes, they're using x variable in here. All right, so here is a typical trigonometric function. I want to know the amplitude. The amplitude is the number that appears in front of cosine. Now, in this case, that number is 4. Now, somebody might think, well, I don't see 4, I see negative 4. Basically, whatever this number is, the absolute value of it is going to be the amplitude. So if it's negative 4, it's 4. If it's positive 4, it's 4. Either way it goes, the amplitude is going to be 4. Next, we would have the period. The normal period, and you will need to have this memorized, the normal period for sine, cosine, secant, and cosecant is 2 pi. The period for tan and cotan is pi. Now let me repeat that a time or two. The period of sine, cosine, secant, and cosecant is 2 pi. The period of tan and cotan is pi. You've got to know that. So when I want to know the period of this thing, I start off and I know the period, as we just said, of cosine is 2 pi. I'll take the period of cosine and I will divide it by the coefficient in front of the angle. So I would have 2 pi divided by 2. 2 pi divided by 2 would be pi. So our period in this case is pi. Phase shift or horizontal shift will always be the negative of the constant divided by the coefficient of the angle. So I've got negative, and the constant is negative 4, divided by the coefficient of the angle, which is 2. Negative and negative is positive. 4 divided by 2 is 2. So I see that the phase shift is a positive 2, or the horizontal shift is a positive 2. If we were grafting this function, we would pick it up and we would move it to the right, positive 2. Like the function that I had, the graph I had up there a while ago for cosine, I would pick it up like a Brandon arm, I'd move it to the right 2, and I'd set it back down. That's what we have for a horizontal shift or a phase shift. The next one is the vertical shift. Whatever's setting out here is going to be the vertical shift. I see that number's 3. That means I will pick it up and I will move the whole graph up 3 and set it back down. If I have that cosine graph that we had a while ago, we would pick it up, move it up 3, and set it back down. Now, a lot of times, instead of being here, it's here. A lot of the older books put it here. It seems like the newer places now that they've moved it to the front instead of the back. It makes no difference where it's added. It can be added back here, added in front, makes no difference. It's still a vertical shift. Reflection. If I have a negative in front of the whole thing, I would get a reflection across. That would be like a negative in front of the y, and as you've known it, but we did before, a negative in front of the y gives me a reflection across the x-axis. A negative in front of the x would give me a reflection across the y-axis. So a negative in front of this right here would give me a reflection across the y-axis. Now, we don't write that down. I put it there to help me remember that we'd be talking about it. We don't write that down when we're doing amplitudes, periods, phase shifts, and vertical shifts. But we know that when we start grafting this thing, we will have a reflection across the x-axis because that's like having a negative in front of the y when it's a negative in front of all of it. And we'll talk about that as we get to the problems that use it. Okay, again, this was a made-up problem. Let's go work some that they made up instead of us, or instead of me. Okay, let's look at problem number, let's do number, what did I write down here? I didn't write it down, excuse me. Okay, let me just look, see what looks good. Let's do number 6. They have f of x equal, and I'd ask you in class, well, f of x equals the same thing as saying what? Well, that's the same thing as y equal. Usually when they put f of x, they're talking about function. They put y of x, they're talking about an equation. We know they mean the same thing. So we're going to graft this function right here. Now, a lot of times, and they didn't on this one, I thought they would have. They will when they get down starting at 19. But we would, you know, a lot of times we'll name the amplitude, the period, the phase shift, vertical shift before we start the problem. Let's just go ahead and do it anyway. All right. The first thing we would do would put the amplitude down. That's like a 1 in front of that. I got an amplitude of 1. Put a phase shift. Well, there's not anything. There's not an x minus something here. The phase shift is 0. We got the amplitude, the phase shift, the period. There's not a number in front of this, so we take 2 pi and divide by whatever's there. So 2 pi divided by 1 tells me that I have a period of 2 pi. And then the vertical shift, I've got a number there, so I see that the vertical shift would be -2, like so. The order I write these in really makes no difference. Usually they put period in front of phase shift, but it makes no difference. I should have, but I didn't. So usually we see that first. Sometime, and I probably ought to do that. If I look at answers in the back of the book, and they're probably going to put them in the order of this. Again, the period is 2 pi, and the phase shift on this was 0. How do we get the amplitude? Well, the number in front of cosine is 1. How do we get the period? The period of cosine is 2 pi. We divided 2 pi by the coefficient of x. In other words, we divided by 1. 2 pi divided by 1 is 2 pi. Phase shift, there's nothing out here with the x, so there's no phase shift. Vertical shift, I've got a -2 by itself. So we're going to take our base cosine function, which you are going to memorize. We had an amplitude of 1, so this is 1, this is -1. We had a period of 2 pi, so this is 2 pi. This is 2 pi divided by 2, or pi. This is pi divided by 2, or pi halves. This is this plus this, which would be 3 pi halves. So there's my base cosine graph. The only thing that I have going on with this is a vertical shift of -2. So everything got moved down -2. Now I do this, it doesn't have to be that way, and you're not going to see it like this in the back when you look up the answer. But what I like to do is I like to put the line that goes right down through the middle of it, and I like to move it either up or down, whatever I want to move it. So we're going to move it down 2 spots. So it comes down, and I see that little line that this thing is swiveling across is at -2. The amplitude is 1, so this right here was 1 above that, so I'm up here. And we're going to label it the same way. We got pi halves, we've got pi, we've got 3 pi halves, we've got 2 pi, like so. And I should have labeled them, but I'm just copying them down so I didn't go through the procedures like I normally do. All right, so when I move this down to, it now is here. It went through there. It came down one more here. It goes through there, and then it goes up to here. And we have a graph that looks like this. It's like we took this thing and we moved it down 2 units and we set it back down. And there would be my graph of this function. Okay, let's do another one. Wished I had y'all in class right now. I'd like to hear the questions that you might be asking me, but we don't. I guess I'll get a chance to see them on comments this afternoon. Well, let's go down to a problem like let's go to number 14. Okay? We want to graph g of x equal negative 2/3 cosine of x. All right, I've got my base cosine graph, which we figured out was this. We're going to have that memorized. I've got a negative in front of it. Negative in front of all of it is like a negative in front of the y. Negative in front of the y indicates that I will get a reflection across x. Now guys, this is not new stuff. Reflection across x, reflection across y. We did that when we were doing graphs in Algebra 2, college algebra, and even pre-calculus. So I get a reflection across the x-axis since the negative is in front of all of it, reflection across the y. If I reflect that across, then I will get a graph that looks like this. I took it and reflected it across the x-axis like so. The amplitude stayed the same. What is the amplitude right here? 2/3. Absolute value of negative 2/3 is 2/3. So it comes up to 2/3 and it goes down to negative 2/3 like so. What is the period? Well, there's nothing that appears in front of cosine, and the period for sine, cosine, secant, and cosecant is 2 pi. So the period is 2 pi. Half of 2 pi is pi, half of pi is pi halves. Pi halves in pi is 3 pi halves. So the period was 2 pi. Phase shift, there wasn't any. Vertical shift, there was nothing grouped with the x. There's no phase shift. Vertical shift, there's nothing being added on to the whole thing. Vertical shift was 0. There's my graph. Again, it sure would be nice to say, questions right now and get them fed to me, but we don't have that opportunity. Let's look on down at, let's look at number 20. I bet you guys wished I was doing some odd on here too, don't you? Let's go ahead and do 21. I'll let you do an odd one. You'll like that. Okay. Amplitude. 1. Doesn't make any difference whether it's positive, negative. The coefficient of the sign is 1. Period. Oh, but that changed, didn't it? I've got a 3 in front of the x. We've memorized that the period of sine is 2 pi. And to get the period, I'm going to divide the 2 pi by the coefficient of the angle. So I've got 2 pi divided by 3 for the period. Phase shift, there's none. There's nothing grouped with the x. So phase shift is 0. Vertical shift, there's not any. There's not any setting. There's not a number out here like +5, and there's not a number in front of it like a +4 or something. So the vertical shift is 0. Now we're going to start off, so here's our information. We're going to start off graphing this thing. I start off with the base graph of sine, which we all are going to have memorized like this. This is a negative, so what did that do to it? Well, the negative's in front of all of it, so it reflects it across the x-axis. So I've got a graph that looks like this. I got an amplitude of 1, and remember, we're going to always label these. Amplitude is 1, so it goes up to 1 and down to -1. I got a period of 2 pi. Now you're going to see why we labeled it like we did a while ago. I've got 2 pi thirds. I said a period of 2 pi thirds. So my period on this thing is 2 pi thirds. I'm going to divide that by 2, and when I do, I got 2 pi thirds divided by 2. I'll write this up here. 2 pi thirds divided by 2. That means 2 pi thirds times 1/2. Dividing by 2, multiplying by half, we all know is the same thing. I see that the 2's cancel out, giving me pi thirds. And remember, we're going to take half of that. So I got pi thirds times 1/2. Pi thirds times 1/2 gives me pi sixths. I hope this is showing up here because we're going to mess up if it's not. All right, so I see that this is pi sixth. I know that this is going to be pi sixth plus pi thirds. I'll write that a little lower to make sure that you're going to be able to see this. I'm going to add these two together. So I've got pi thirds plus pi sixth. In order to add these, I need to change this to 6. So that's 2 pi sixth plus pi sixth equal 3 pi sixth or pi halves. I now have it graphed. Again, I sure wished I could ask you guys questions right now. We could have a little discussion on what went on. I have absolutely no doubt that right now I'd be getting a question or two, but I don't have that opportunity. You do not have that opportunity. Work on these and feed me questions. Now I'm going to erase this. I think you'll be able to go back and forth. Hopefully you go back and forth on this video. So I'm going to erase this problem, and I need to remember which one it was so I don't work it again. That was number 21, wasn't it? So I worked one besides 21, or below 21, I should say. And let's see. Let's do number. Oh, I wished I had you here. I'd let you be asking me which one I needed to do, wouldn't I? Let's do number 31. Okay. Now they say find the amplitude, the period, and the sketch, but we're doing a little more than that. We've got the amplitude. I've got a 1/2 setting in front of the function, so I know that the amplitude is 1/2. The period, I've got a pi in front of the angle. Therefore, I've got the period of cosine, which we know is 2 pi. And I'm going to take 2 pi and I'm going to divide it by pi, and it gives me a period of 2. We would next do phase shift or horizontal shift. Well, there's nothing grouped with the x over here. It's not like an x plus 3 or something like that. So the phase shift was 0. Vertical shift, yes, we have a vertical shift. We see that we've got 1 added on to all this. So we're going to use this information now to graph our function. Now, to graph the function, we will start off with the basic cosine graph, which we have memorized as this, as our base graph for cosine of x. Our amplitude is 1/2, so we'll label this 1/2, and we'll label this 1/2. Our period is 2. That means that this comes out to 2, like so. And half of 2 is 1, and half of 1 is 0.5, and 0.5 and 1 is 1.5, like so. The only thing left now is our vertical shift, which means we're going to move everything up 1. We're going to take this and move it up 1. Like a Brandon arm, we're going to pick it up and move it up 1. So our 0, and again, do we have to do this? Well, no, you don't, but I think you'll be better off if you do. There's going to be the little line that we're rotating across. So up here at 1.5 is where this one's going to start off at, and at 0.5 is where this one's going to start off at. That was a negative 1/2, by the way. When we move everything up 1 unit. So I would have a graph that starts up here, crosses here, goes down, and goes up. When I take this thing, I move it up 1 unit. Where did this occur? Well, that's at 0. Where did it cross the axis that it vibrates around? Well, that's at 0.5, isn't it? And where did it hit its low point? That's at 1. Where did it cross again? That's at 1.5. And where did it hit its maximum again? That was at 2. There's our graph. Now, we know that this thing goes forever. It just keeps going, just all the way out to infinity, all the way out to infinity. Now, when you graph these, of course, you're doing the odd numbered problems, so you want to check them in the back of the book. Also, I want you to graph them. I want you to go to your calculator, y equal. I want you to put in y equal to 1 plus 1/2 cosine of pi x, and then I want you to go to the upper right-hand corner, hit graph, and see if this is not what you get. Now, when you look at your graph on there, you're going to see that it goes to the end of the screen and it goes to the end of the screen. But I want you to do it both ways. I want you to graph it without a calculator, then I want you to turn around and graph it with the calculator. Now, I'm going to stop at this point on 5.3A. I want you to try to work the problems that I had written on the board for you. Well, I still got them up there, don't I? I want you to work 1 through 4 all. I want you to work 5 through 31 odd. And then I want you to give it a good shot. I want you to work at it. Before you ask me questions, I want you to try to work some problems on that stuff. And then you're going to send me some problems. I would probably expect, to be on up in the morning before I get any. And then I'll try to get back with you sometime during the day and answer those some of those problems that you asked, and we'll do it the same way you did right here. And then tomorrow, we're going to go and do 5.3B, and we're going to add some more of these problems, some that get a little more complicated. Okay, guys, again, you guys take care of yourself. Be careful. Don't do stupid stuff. You do what the experts are telling us to do. You keep your hands washed. Use a little disinfectant on them, a little sanitizer on them. Stay out of crowds. Stay away from sick people. We'll be talking to you later. Have a good day.